8.5, we're talking about trigonometric form. I will be calling it polar form. Okay? Polar form, you're going to need r and theta, but all that is magnitude and direction. So when we're talking about polar form, we're really just talking about magnitude and direction. So then they start off with something that I think you should already be familiar with. They give you a vector in this form. This is called rectangular form, where they're giving you an x and a y, basically. So you might be more comfortable calling it 2, -3 inside pointy brackets. But they're going to write it in this rectangular form with the I on it for rectangular form. So check out this diagram down here. They've got a resultant force drawn. But notice the two vectors. Let's call this vector A. This is vector A, 4 plus I. And let's call this vector B, 1 plus 3I. They're just adding these two vectors. It is pretty easy to see where that 5 comes from. Just add the x coordinates. 4 plus 1 is 5. And then add the y components. I plus 3I is 4I. That's how they're getting their resultants. Okay? Their A plus B, or their resultant force in this picture, is just drawn by adding the components. Add the x's, add the y's. So example 1 is an example of that. Find the sum of these two vectors and then graph both complex numbers and their result. We're going to graph a total of how many vectors here? 3. We're going to graph both of the vectors that they show, plus we're also going to graph the resultants. We're going to graph 3 vectors. So first thing, let's find the sum. That's easy. Okay? Find the sum. We're going to add the x parts. 6 plus -4 is 2. Add the y parts. -2i minus 3i is -5i. So there's your sum of those two complex numbers, or your sum of those two vectors, your resultant. Now we need to graph both complex numbers and the result. So if you look, the numbers go up to 6. I'm going to need to draw an xy coordinate plane, but I only need to go up to 6. The first vector, 6 minus 2i, treated just like 6 comma -2. That's where the head of your vertex would go. So go over to 6 and -2. That's where the vector is going to end up. That's 6 minus 2i. And then the other one says -4 minus 3i. So look at -4 comma -3. About right there. -4 minus 3i. So we've graphed our two original vectors. We've graphed our two vectors. Now we're also going to graph the resultant, 2 minus 5i. So 2 minus 5i is going to be about right there. And so remember back to some of the sections before where we've had to draw the resultants. This looks like a dog walker problem, and that resultant vector should be to the opposite corner of our parallelogram. You think that's what happened? Looks about right. Don't draw that in. They don't really care for us to draw that parallelogram. They wanted us to draw those two vectors, those two complex numbers, and the resultant. So that's it.